finding points on the graph where the tangent line is horizontal is going to be a very, very important skill. Okay. And again, if none state that. So we're going to find out. Both of the ones that I've given here will have tangent lines that are horizontal. So remember, tangent lines are horizontal means my slope is 0. That's right. That's what that means. When I have a horizontal tangent line, slope is 0, right? It's a flat line. There's no increase and no decrease. That's what that horizontal tangent line means. There's no increase or decrease, no rate of change. Right? The function, for all intents and purposes, has come to a stop. I'm going to write that down. It's kind of messy. All right, slope is 0. And these are important. I want to know, when has my function stopped moving, right? It's neither increasing nor decreasing. That happens when I have a flat tangent line, right? Horizontal tangent line where slope is 0. And so I want to know when this occurs, right? It's an important aspect of my function, is when am I not changing in one direction or the other. And so what you have to do to find horizontal tangent lines, you have to find the derivative. When is the derivative, right, the rate of change function, 0, right? So you have to take the derivative. So in this case, you're going to take the derivative of f of x, set it equal to 0, and solve for x. All right, find the points on the graph where, again, that would be at the x values. All right, and sometimes it's the solve for x, not the derivative, that's the hard part. All right, for this first example, so I'll find the derivative first, and then I'm going to set it equal to 0. All right, so the derivative is just the power rule. I pull my 3 out, so I'm going to write this down because sometimes students struggle with this. So 3 comes out, so it's x to the second divided by 3. So those 3's are going to cancel out. They're going to reduce. Negative 3. So my derivative simplifies to x squared minus 3. All right, first step, find the derivative. Second step, set it equal to 0 and solve for x. And you have to show, all right, remember, especially in the show your work examples, setting it equal to 0 is important. If you remember the last example in the last video, I wanted to know when my velocity was negative 9, right? So I set my function equal to negative 9. Well, in this case, I want to know when my derivative is 0, when the slope is 0. And so it's important that you show that it's set equal to 0. That's a key step that we look for when you're showing your work. All right, so setting it equal to 0, key step. All right, and then solve. All right, so I'm going to use the square root property. So I'm going to solve for my x squared. So I'm going to move my 3 over, so I get x squared equals 3. The square root property is I take the square root of both sides, but when I do, the property is it's the plus and minus, right? When I square, it could either be a positive or a negative. So there are two values, and it's exactly at positive root 3 or exactly at negative root 3. So this function, f of x, my original function up here, has stopping points. Alright, has horizontal tangents. Again, slope is 0 at 2 moments. At x equals positive square root of 3, and again at negative square root of 3. So there's 2 places on this function where it is neither increasing nor decreasing. That's what that means. It's neither moving up nor moving down. It's come to a stop at that time. So at those 2 moments, it's stopped, and that's important to find. So right now we're just practicing finding it. Actually, in chapter 3 is when we kind of go into more detail why this is important. So right now we're just practice finding it. Now that was a simple example. Problem 2 is a more complex. Now, the setup is the same. I want to find when the derivative equals 0. And I need to solve for x. Alright, this one, though, is more complex because the derivative is more complex. Alright, this is a quadratic. Not a quadratic. It's a quotient rule and the chain rule on both the numerator and denominator. I'm going to leave it numerator and denominator. If you want to move the bottom one up and make it the product rule, you can. You'll just have to factor out negative exponents. And if you want to do that, feel free. All right, I'm going to leave it. I'm going to use the quotient rule and the chain rule. All right, my low function is my 5th degree function, my high function. And I got to be careful here because I'll throw myself off because it's 2x plus 3 and 3x minus 2. So I'm going to make sure I'm very careful when I write this one out because I could really easily flip that. Alright, so my low function first. So my low function is 3x minus 2 to the 5th times the derivative of the high, which requires my chain rules. The first thing I do is pull the 4 out. Take the 2x plus 3 raised to 1 degree less, so that would be cubed. Not done yet, right? That's the outside. Now I take it times the derivative of the inside. So the derivative of 2x plus 3 is 2. Alright, so there's the first derivative of the second. Now it's minus, or the low derivative of the high, minus the high, times the derivative of the low, which again requires my chain rule. So first thing I do is pull out the power 5, take my 3x minus 2 raised to 1 degree less, which would be to the 4th, not done yet, times the derivative of the inside, which in this case would be a 3, right? I've got 3x minus 2, so the derivative of 3x is 3. That whole mess all over the low function squared. Alright, so my 3x minus 2 to the 5th squared, so that's going to be a 10, right? If I simplify that, that's going to be 10. Alright, now simplifying this, remember when we simplify this, we factor out the common groups. They have two common groups, right? We're going to factor the common groups. Those are the groups we use the chain rule on. And I should have one left over once I do. So there should be, once I factor out, there should always be one group left over somewhere once I do the factoring. Alright, so I'm going to pull out, well, I can pull out the group 3x minus 2, but I can only pull out 4 of those because I've got 5 here, but I've got only 4 there, so I pull out 4 of those. Times, the other group I can pull out would be the 2x plus 3. I can only pull 3 of those out because I've got 3 in this first term and 4 in the second term, so 3 is it. And so there's the two groups, and then what's left over, and again, I like to do brackets to remind me that I usually have to simplify what's left over. All right, so in the first group, I pulled out 4 of those, so I have 1 of those left over. That's gone, as I pulled all 3 of those out. But I still have a 4 times 2, so that means I still have an 8, right? 4 times 2 is going to leave me with 8. So I have one group, 3x minus 2, and an 8 left over. And I have to multiply those, so parentheses. Then I still have the minus, because there was no negative 1 to get rid of the minus, so the minus is still there. I have in the second term, I still have the 5 and the 2. I only pulled out 3 of these, so I still have 1 of those left over. All 4 of those are gone. So in my second term, I have a 5, 3, so that means I have a 15, and then one group, 2x plus 3, which again, put parentheses because I'm going to distribute that negative 15. All right, that whole mess all over 3x minus 2 raised to the 10. All right, so now there's a couple things that I'm going to do. First of all, I'm going to distribute the negative 8, and I'm going to, distribute the positive 8 and the negative 15. And then I've got 4 of these that I can reduce with 4 of those, right? I've got 10 of them here, which means that'll be reduced down to 6, right, when I cancel those out. All right, so in my next term, what's left in my next term? Well, up top, I only have the group 2x plus 3 cubed. Inside the brackets, I'm going to leave it brackets because I'm going to have to collect like terms. When I distribute my 8, I'm going to get 24x minus 16, and here I'm going to get negative 30x minus 45, all over 3x minus 2 to the 6th power. Almost done with the hard part, the derivative. Alright, so now I just have to collect like terms inside the bracket. So you can leave them brackets, but once I get done simplifying, I typically drop the brackets and write parentheses. Just personal quirk. And so 24x minus 30x is going to leave me with a negative 6x. So negative 16 minus 45 is going to leave me with a negative 61. So that's left over all over 3x minus 2 to the 6. All right. So there is my derivatives, all right? So that's step 1. Get the correct derivative. All right, step 2, which I'm going to do my work over here since I've run out of space there. All right, so I'm going to rewrite my derivative up here. Remember, I want to take my derivative, set it equal to 0. So when I rewrite it, I'm going to set it equal to 0. Because again, that's a key step. So 2x plus 3 cubed times negative 6x minus 61 all over 3x minus 2 to the 6th equals 0. Okay, so now I've got my function. So first step done, right, which was tough. This was a toughie. First step done, find my derivative. Second step is now so now I'm done with the calculus part. Done the derivative part. Now it's the algebra part, which again, sometimes the algebra for students is just as hard as the calculus. So remember, I can't have division by 0, so the only place I can actually have a 0 is in my numerator. Alright, now I have to check to make sure my answer doesn't give me division by 0, but only the numerator can give me out zeros. Only that 2x plus 3 cubed times the negative 6x minus 61 can give me out a 0. Which means 2x plus 3 gives me out a 0. There just happens to be 3 of them, but I only need 1 of them to give me my 0. And the negative 6x minus 61 can give me out a 0. So this is going to give me, there's a 0 at negative 3 halves. There just happens to be 3 of them. And this one's a little uglier. This one's going to come out 61 over negative 6, and that's, I'm going to leave it 61 over negative 6. And so those are the two values where g of x has horizontal tangents. Alright, slope is a 0. So at negative 3 halves, the function had come to a stop. And at negative 61 over 6, the function has come to a stop. So again, it's not pretty. They're not pretty numbers. But those are both places where my function is stopped. And that's important. It's important to know, when is my function neither moving up nor moving down? When does it come to a stop? Alright, and that's where and that was a tough one. Alright, we'll stop there. The next is just going to look at some basic applications.